going down. We're hearing a lot about blockchain. There's a lot of interest right now. But
it's not too far from here.
Everybody, please self-mute. You can. And please, a few things. I guess you could say the big difference with Hyperledger and Bitcoin and Ethereum and those other blockchains we hear about is Hyperledger is a private blockchain. It's a permission blockchain for business, and we're going to go into the big advantages to that and what's good about public blockchains and what won't work for business for public blockchains. Again, my name is
Jim, just one thing. You might want to switch what screen you're presenting because we see the dual screen thing. Is that what you want to present?
No, I don't. No,
Okay,
thank you for letting me know that.
Yep, sure. Yeah, no problem.
This is different all the time.
Yeah. Oh, there you go. Perfect.
How's that now? Okay,
Yep,
great.
Right. Yep.
Okay. Anyway, my name is Jim Sullivan, and I'm a software engineer, and I've been just learning about all different technologies. I'm a software developer. I guess once you're a software developer, you can really pick up a lot of other technologies. So in my time at IBM, I used to work for IBM right there at 590 Madison Avenue, and I work with DevOps, cloud applications. Also, I'm a methodologist. I had to learn the safe agile methodology, and I got interested in, I used to be on the Hyperledger team at IBM. I was with the WebSphere brand, and a lot of my teammates transitioned over to Hyperledger. And but now I've been working on my own for a while, and I also know and certified in Corda, which is an example of another permissioned or private blockchain. So let's talk a little bit about Fabric highlights. So those of you that are very familiar with Fabric, there could be a lot of you out there. The first few slides will be a bit of a review. Then we'll talk about system administration and then application development. So a little bit about Fabric and its sibling Sawtooth. They are permission blockchains. So what really is great about blockchain is that it has an immutable ledger, and it is you can certainly run what we call smart contracts on there, which are really transactional applications. With blockchain and Ethereum, the downside is that it is quite anonymous. So we don't know who is out there transacting. We can see how much the transactions are, but we can't see who they are. And that obviously doesn't work for business. So with Hyperledger, we have that permissioned. So we do know all of the actors. It can be broken down in a modular way called channels. We have consensus between the transactors. We have an open smart contract model. Again, sounds really fancy. It is, they are applications that complete transactions. And we are also able to hide data, so data privacy. For contract development, there is multi-language support. Go is a big language, but also Java, JavaScript, and there is support for the Ethereum virtual machine and Solidity. There is a governance versioning for smart contracts and the endorsement again for consensus. So you probably have heard of proof of work as consensus, and proof of work is needed on a public blockchain, but on blockchains like Corda, on blockchains like Hyperledger, we don't need to do consensus like proof of work, because the ledger is small. It is not on. It's not spread across hundreds and thousands of nodes. It's very localized. So we don't have many copies of the ledger. Ethereum, Bitcoin, these are all examples of single ledger blockchain. So there's one copy of the ledger, but it exists on every single node. Well, as you can imagine, that node needs to be synchronized. So we all need to know, well, what is the real state of the ledger? Who owns what? So we need a very involved, a very complex consensus algorithm, like proof of work or proof of stake. We don't need that on Hyperledger. The transactors say, I gave the $10 to Jamil. Jamil said, I own it now. I consent, and I say, I no longer have the $10. Jamil has it, and I also consent. And that's what we need for consensus. So a few things about the Hyperledger architecture, or we have peer nodes. So one of the criticisms of public blockchains is what? They are what? It begins with an S. They are slow. The Ethereum the Ethereum network can process about 15 to 20, you can argue about it, transactions per second. If you compare that to the Visa network, that does about 70,000 transactions per second. So the designers of Hyperledger said, well, what are some ways that we can speed up transactions, have transactions take less time? Well, one of the ways we could do it is we have specialty nodes. So Hyperledger has specialty nodes, and Corda has specialty nodes, whereas Bitcoin, Ethereum, they have just one type of a node, and that's it. They are all peers. So we could see here we have a peer, a set of peers which actually also specialize. We have orderer nodes. We have a certificate authority for cryptology, for encryption. We have our ledger. We have channels. Everybody, please try to self-mute. We have our contracts. We have our endorsement, and we have our membership. So this is all important. If everybody could please mute. We need a membership service because we want to control what identities, who's on. We need in business, we need to transact with individuals that we know who they are. So if I'm going to have a transaction with Jamil, I need to know that that is indeed Jamil who I am transacting with. Whereas if we look at blockchain explorers for Bitcoin, we sometimes don't know who we're transacting with, and quite often it doesn't matter, or we don't want to know. So up here, we have our peer types here. That's that fundamental unit of the Hyperledger network. So it maintains a ledger and a smart contract, and they also specialize. So we have anchors, endorsers, committing peers. So our peers are maintaining and connecting with the applications that run on the client side, the ledger and the smart contract. So peers can be, as we build up our network, peers can be created, started, stopped, reconfigured. And with peers, there are a set of APIs. Another node that makes up the network is called the orderer. So the ordering service, or the orderer, is a mechanism by which the applications and peers interact with one another. And they ensure that every peer's ledger is kept consistent. And they mediate these special nodes, and they run a messaging service. Kafka, which it says here has been, as a version 2, has been deprecated. I'm surprised to see that. But also, you may be aware that even though Hyperledger is not an IBM product, IBM is one of the more loud contributors to the Hyperledger product. And so now MQ, it doesn't say that here, but MQ messaging is also available with for Hyperledger. I would stick with RAF because MQ, like every other IBM product, is more complicated than it needs to be. And our ordering service broadcasts the messages to the peers, and then all peers receive add the blocks of the transactions for the same order. And the ordering service works first come, first served basis. But the orderer does, like it says, make sure that the orders of the transactions. Yes.
So since you have controls, we have somebody who's not muting, and it sounds like they're watching a Western. Maybe you can get the name of the movie, but later, I don't know if you can like go to your controls on the right and force mute. There are two people that are not muted. There's a Sam and Renee that are not muted. And if we can mute them, that'd be great.
Okay. I apologize, everyone. We're taking a little break here.
Yeah, it looks like Sam muted. Okay, the right person. Thank you, Sam. Appreciate it. Okay, I think we're good now.
And as you can imagine, the order of the transactions does matter, and that is a key part of what the ordering node does for us. So we want to make sure that before Jamil accepts the transaction, that I actually make the offer for the transaction, and that's what the ordering node is giving us through its messaging. So again, Raft is considered to be easy to set up, and there also is Kafka, which is another option, and Raft is supported natively. So certainly, again, it's if you've ever used Uber or any service similar to that, behind the messaging behind the scenes is either Kafka or Raft. So you've used one of these products, and the difference here is that Kafka uses a pool of servers, and the admin of the orderer specifies how many nodes they want, whereas Raft allows users to specify which ordering nodes will be deployed. And also, it says here, Raft is the first step toward Fabric development of the Byzantine fault tolerant ordering service. So this is actually, if you want to get fancy, this is the consensus model, Byzantine fault tolerance. In other words, we both sign, or we both say, yes, I agree with that transaction. So this is, I like this. This is, I guess, a little simplified, but it brings into, it illustrates just what we've been talking about. So we have our peer here, and notice our peer is connecting with our application. So this is our client, and our client makes the proposals for the transaction. So we have the peer connections. We have our chain code that is running on another peer, most likely here. And then we also have our ledger. Again, we're only showing it here. We're only showing one ledger here, but their Hyperledger, just like the name implies, has several ledgers. So we can work with different organizations, different actors, with different ledgers. And you may hear the term channel, and the channels are the organizations all with their own ledgers on Hyperledger. And we can see the order here. The transactions are sent to the peer blocks to update the ledger. The ledger, interestingly enough, is distributed amongst the peer nodes. So a little bit different from Bitcoin or Ethereum, where there's just one copy of the ledger. Here, we're going to have the ledger completely distributed amongst the nodes. So if you wanted to see one view of the Hyperledger ledger, you would have to do the sum of all of the ledgers on all of the nodes. Very, very similar to Corda, the way that that works. And if you've ever heard the term distributed ledger technology, DLT, that's what they're talking about. And so all blockchains, Bitcoin, Ethereum, EOS, they're all distributed ledger technologies. However, not all distributed ledgers are the exact same as your traditional blockchain. We also have a certificate authority. So we use keys. We use key pair encryptions. So we need a certificate authority to exchange those keys, and that's what that's doing here. So just like when we use a shopping cart online, we have our SSL certificates, HTTPS. You might have seen that, right? We're on Amazon. That's what's going on here. So we have a certificate authority. So every participant has a pair of keys, and we use those to encrypt and decrypt the transactions. And a little bit about the ledger. So it stores factual information about business objects. So it does not, I used money. You can transact dollars on Hyperledger. It's not a big use case. It's usually typically different types of assets, but we have facts about who owns the asset at any given time. So who has possession of a particular item. It could be in a supply chain. It could be a license. It could be something like that. Who has possession of it? So the ledger consists of two parts. We have the actual full state with all of the blocks in it, with all of the transactions. And we also have what we call the world state. And the world state is a database, and it is a NoSQL database. So it's a little bit different from the traditional databases that we may be aware of, MySQL. But what the world state gives us is the top of the ledger, or the current state of the ledger, and that's very common in with blockchain, because you think to yourself, well, blockchain it's not really a traditional relational database. It's a ledger. It's different from a traditional database. It's very hard, though, to find a blockchain node where somewhere in there's not a database that is giving us the top of the ledger. I think we all know about, those of us that know Corda know that there is also included with the Corda node, there is a database, a very lightweight one running, giving us the current state of the ledger. So we see it right here. I like this slide. I hope this is big enough for everybody to see. But we're seeing here the whole immutable source of truth. So this is all of the blocks with different transactions here. They're all hashed, all dependent upon one another. But the state database gives us what? Right here, the latest key values, just like JSON, the key pair values. We can see asset name. There's an asset name in there, owner Jerry. Hopefully you can see this, the date, a version. So this is giving us that key information, which we want to use, well, certainly for transactions, and we also want to use for runtime queries. So the ledger is a sequenced, tamper-resistant record in Fabric, and it's the result of different transactions that have taken place by the submitting parties. So all of the blocks are hashed, and that hash is used in the preceding block. So I like the term tamper resistant, because I guess in theory, the blocks could be tampered with. However, though, as a lot of you know, the hashes that are in there that are part of the block are very, very sensitive to changes. So a lot of people think, well, hash, that's how I'm encrypting data. Well, with hashing and blockchain, we don't use hashes for encryption. We use hashes to make our data tamper resistant, because if anyone would get in and change any data in any of the blocks, the hash would change, and we would know that, and we would be able to take action against that block that no longer is part of the chain. So we could either restore it from backup, but we can take action. So our ledger features here, we can obviously query them. We can do key-based lookups. We can do read-only queries against the world state database, and we can also do historical queries like we just saw on with the blockchain, with the transaction history. And the transactions consists of key value pairs that were read in and added in chain code. So the chain code did the writing. And the transactions contain signatures of those endorsing peers. So that is the consensus. So I complete a transaction, I sign it, Jamil completes, Jamil's on the other side of that transaction, Jamil signs it, and we are at consensus. And then the transactions are ordered into blocks and delivered from the ordering services back to the channel. And the peers validate against those endorsement policies prior to appending the block. because we have to have consensus. That's true with any blockchain. We have to have consensus before the block is appended. And then once that transaction is validated and committed, it is hashed and is immutable. So a channel's ledger contains all of the configuration block defining policies, access control lists. So with Hyperledger Fabric, we have a membership, a user service. So we have this membership service because we have to know who we're transacting with. And unknown parties obviously are in business, really don't work. I guess there could be exceptions to that, but very rarely do we find that we need to transact with unknown parties in business. And again, there is this concept of the multiple ledgers. So we have our peer here, and we have our multiple ledgers. So the multiple ledgers are organizations, usually, that we are doing business with, and we could also have typically. You hear the term consortium. So we might have a consortium with several different, say, vendors. Say we're in the healthcare, or we're shipping pharmaceuticals or cosmetics. We could have channels with several of our suppliers. And a channel is that mechanism by which trusted peers are all working on the blockchain together. So a channel is a subnet or a peer that has essentially has its own ledger, and I transact with from my ledger. Or my channel, I transact with the organizations that are part of another channel. And channels have defined members. They are anchored with peers, and they run chain code, and they use the ordering services. So each transaction on the network is executed on the channel, and those ordering nodes build the blocks, and the blocks are eventually sent back to the peers. So each peer joins the channel and has its own identity, and it's given membership which authenticates the peer. And the election of each peer for each member on the channel determines which peer communicates with which ordering service. And no ledger data can pass from one channel to the other. So this is the privacy right here of, well, I guess privacy is a good term, or the this obviously enforces that no other vendor, no other organization, no other part of the consortium can see the transactions of another. So if I am Walmart and I'm working with various farmers, no other farmer that I'm getting tomatoes from can see each other's transactions or data. Everything is kept secret, or, well, kept private. And we have our smart contracts. So smart contracts are nothing but business agreements that are encapsulated in code. So sometimes I think of them as applications. They're special applications because they are committing transactions. So smart contract versus chain code. Smart contracts are written in chain code. So smart contracts are meant to be the logic that gets executed on the ledger in order to manage and maintain the states of certain assets. So the states of the assets, right? The attributes of the asset. Who owns the asset? When it was transacted, where did it come from? What are the timestamps? And the chain code is what the smart contracts are written in, and that's what's deployed to the Hyperledger network. So one of the big things about smart contracts they are literally compiled and deployed, and they have an address on the blockchain. One thing that's different about Hyperledger is I can actually overwrite the smart contracts. So even though I'm deploying them and we would think of them as immutable, they are updatable on the blockchain. That's not so with a lot of other blockchains. With a lot of other blockchains, you've got to redeploy, give your smart contract a whole new address, and then interact with that smart contract on its new address. You also have to point it back to all of the previous transactions, which can be a little bit of an effort. Smart contracts, they obviously have an ID. They complete transactions. They have a state, so you can see a transaction request here. They look at the current state of the ledger, so they can get that from the world state typically. They have business logic code in there. They can accept or reject the transactions, and they communicate back with the ordering service. A few policies here. So policies are implemented at different levels. So each domain governs different aspects of how the network operates. We can see here we have a system channel, of course, consortium members and the blockchain structure. We have an application channel where the business logic is executing. And then finally, we have our ACLs and smart contracts. So this is our membership, our users, and the data and events of our smart contracts. So different policies running at different levels. And we can see them right here. So this is the governance right here. So we have our system channel that has all of our consensus, our consortium membership policies, our applications here, and we can see here our smart contracts, our ledger data, and our events. And our endorsement policies, they define the smallest sets of organizations that are required to endorse a transaction in order to validate it, and they also describe sets of the chain code. So the principles that are described in the endorsement policy, we can see here: member, admin, clients, peers, and here's a little bit of the syntax for endorsements. So we can see here our administrators, our members, clients, peers, they all have a part of the endorsement or the consensus for a transaction. And our membership service is how we get our identity on the blockchain. So we have a local membership service, and we also have a channel membership service. So we can we can transact with whoever we're supposed to on the blockchain. And there are membership services, a membership service provider who gives us our certificates. And our certificates, just like the certificates on a HTTP, our certificates have the public key and they have the private key. And the public key is our identity, so everybody knows it's Jim with this address or with this public key. And I also have my private key. So if you need to send me a message or a transaction, you encrypt it with my public key and you know who I am. And I'm able to validate who I am because I also have my private key. And then I decrypt the message with that private key. And since nobody else has the private key, that's also considered a signature for me to sign the transaction. And certificate authorities generate their certificates for the different memberships with the permissioned identities, and the MSP that gives us our identity and our role on the Hyperledger nodes and channels. And when a user is registered with the Fabric CA, a role is given. So admin, peer, client, or member must be associated with a user. So the system administrator. So that was all a lot about Hyperledger and what makes it the same and what makes it different. But the role of the admin is, number one, to interact with the chain code, manage the peers, and operate basic certificate authority levels. So being a Hyperledger admin involves the topology of the network, operating the chain codes of the smart contracts, administration of identities and permissions, and also configuring, backup, and much more. Some main tasks about a system administrator. Doesn't say it here, but Hyperledger is installed. You're probably aware, a lot of you have probably already installed it. You're probably aware that it runs within Docker. So you have to download Docker, and you install it. You install it through Docker. And those of you that know Docker probably know that it does simplify the installation to a certain extent. It runs within containers, and the containers communicate with one another. So some of the system admin's main tasks are install and configure the network, diagnose and troubleshoot logs, members, and identities on the network, and network maintenance and operations. So this is pretty typical of most, I'll say, enterprise software, most large software products. And from a technical standpoint, we have to be familiar with Linux command line, Bash, or any of the shells. I just talked about Docker and containers like Kubernetes. Oh, did I mention NoSQL? So the world state of the database is typically a NoSQL. I have heard, though, you can use relational databases. I'm not aware of any examples with it, but it's good to be familiar with NoSQL and either something like a couch database, and also blockchain and distributed ledgers. All of these you really have to know these pretty well. But once you do, none of these are all that complicated. Linux command shell, I'm sure we all know that. Docker it's like virtualization, like a virtualized container. It's very, very similar to that. Kubernetes is also a containerized product as well. It runs applications out of a container. And you can, if you know relational databases, you can certainly pick up NoSQL databases. Oh, hooray, hooray, there is an exam for Hyperledger system admins. And in order to have a lot of credibility, to let everybody know, broadcast your achievements, you can take the exam. And there are a lot. There's not really at this time that many certified system administrators. I believe that that could have changed in 2020. I don't have the exact numbers, but I know that since the certification went live, there were a lot of enrollments in classes, but so far a relatively small number has actually completed that process. So in comparison with system administration, Hyperledger develops primary tasks to work with the one major component is the contract code. So again, very, very similar to your infrastructure, your DevOps, right? You have your developers who are building applications and deploying them and running them and improving them all the time. And then you have your administrators who are stabilizing the applications, getting them to run, troubleshooting, and making sure the infrastructure is up and running. So the developer's main tasks are understanding and defining transactions, running queries, building the applications on the smart contracts, understanding the key value pairs. Again, the key value pairs are just like user, and the value of user is Jack. Date, and the value is date, right? Just very, very JSON like. And to identify potential private data, submit and evaluate, and query transactions by running smart contracts. And some of the technical requirements for Hyperledger developers, well, understanding the whole transactional approach with smart contracts, knowing that is really important. You can use JavaScript, Java, Go, or Python, and the most famous JS framework that is currently used by Fabric developers is Node.js, which is very closely related, if not completely identically related, to JavaScript. And there is also an exam, hooray, hooray, for Hyperledger developers. So you can certainly discuss this with me or others that are part of the Linux Foundation. So if you're interested in becoming a certified developer, there are classes available. So what did we discuss here? I guess we're coming really close, 40 minutes to the time that we wanted this presentation to go for. So we discussed the Hyperledger product itself. There is no native token. I understood that they were actually discussing having a coin for Hyperledger for version 2, but currently there is no native token, which is probably a good thing. Because we can work with any asset on Hyperledger. If you're interested in training, please come back to us. There is lots of options for training. It's a good time. You can run Hyper. There are some articles here. I've run it on AWS and on other. We've also run it on Azure. So that might be the easiest way to get it up and running. And some other resource articles here. So certainly send us an email. You probably can't click on any of these links, but there is lots of information available for Hyperledger. Best place to go really is the Linux Foundation website.
Yeah.